Welcome back to another episode of the Science Series with Roberto Sussman, where we take a closer look at the research, break down the data, and separate facts from assumptions. What were the key findings of Roberto's review of the laboratory studies?
We revised if they were testing the devices under the optimal regime. That because the optimal regime is supported by thermal physics, right? And so it is not so I believe or no. There are physical laws that tell you the power levels at which the device works with maximal thermodynamical efficiency, and the cycle of energy supply and energy absorbed is the most efficiently possible with less residual heat accumulating, and we check if they do that. But we also check other things. For example, any experiment has to be reproducible. In principle, you should be able to replicate the experiment. An experiment that is announced and is not reproducible, it's not worth, right? So how these experiments on emissions of e-cigarettes can be reproduced? The authors have to provide all information on the devices: power, resistance, the mixture of the liquid they are testing, because things change if you change the mixture, the proportion, the amount of nicotine, also the flavorings, if you can supply that you have to supply that information also. And you have to supply at what power you are testing them, and at what coil resistance, and also the airflow. The airflow is very important. Sometimes they dismiss it, but it's very important. So it's one criterion. If the authors do not supply all the necessary information, they get a bad mark because the experiment is unreproducible, right? Another is that the authors have to test devices that are not obsolete, right? What's the point if I am testing a cigarette that was patented or was sold 12 years ago? It's irrelevant because nobody is using these devices anymore. Or also, the devices have to be new, or if they are not new, you have to specify how they were stored. Like some studies are testing devices that were manufactured 6 years ago, 5 years ago, and they don't tell you how these devices were stored. And besides the point, these devices are no longer used. So there are many experiments that are testing old or obsolete devices and provide no information. Another point. So we check this. Other problem is that what happens if you, for example, there is one study that, in my opinion, is among the worst studies. They tested 5 devices, a Joule and other devices. They put them in the machine and they pop them every 8 seconds, 300 times. Of course that you get overheating. Even if the airflow is right, you get overheating because, as I explained, the electronic cigarette works on a thermal cycle. Energy supplied, it is absorbed, and some residual always remains. Now, you need some time for this residual heat to settle down, to relax, right? To dissipate, right? That time can be, I don't know, at least you need half a minute for that, or 20 minutes, 20 seconds at least. If you pop them 300 times every 8 seconds, there is no relaxation of the residual heat. It accumulates. And once it accumulates, because there's thermal conduction between all the elements inside, the coil temperatures will rise up, and it is an enormous overheating, right? So the puffing cycles have to be, at least you have to leave 30 seconds between one puff and the other. And you need to do a lot of puffing, because that's another point. If you are puffing in a machine, this device, then after you do 50 times you puff it, right? And then you let it rest, and you do another 50. And you compare the blocks of 50, and you can see that the chemistry of the liquid and also the quality of the aerosol is changing, right? It's changing gradually. Users can feel that. I have put new liquid here, and it has a taste. But after 100 times puffing it, the taste is slightly changing, right? And if you continue puffing and puffing and puffing, it can deteriorate. It's not the same as overheating, but there is a taste deterioration as you puff the devices. Now, a machine is puffing in a reglementary way. Humans don't do that. I mean, I don't have a clock here, say 5 seconds. Next puff. Next puff. We're not like that. We're not regimented. So this is not likely to happen among humans, right? Because humans, if you're nervous, you're waiting for the boss or whatever, and you're nervous and you puff a few sequences of very fast puffs. But then later you will puff in a more relaxed way, right? But in machines, it is important to notice that when you do regimented puffing, the quality of the aerosol will be changing after 100 puffs, right? Has to be taken care of. And essentially, and also, once you get your numbers, you have to make a toxicological comparison. And that toxicological comparison has to be well done, because the concentration that you get from the machine is a concentration of the substance in the volume of the puff. But when you inhale, this puff is diluted in your air, in the air that you breathe. The typical puff volume is of the order of, let's say, 50 milligrams. But the volume of the air that you inhale is 500. So you have to take the quantity and to compute the concentration in the air that you breathe, not in the volume of the puff that is detected by the machine. Many articles do this error, and by computing a concentration in a small volume, you have an overestimation of the concentration by a factor of 10 or 20, right? So we checked all these. You see there are 5 conditions: reproducibility, correct puffing parameters, not all devices, puffing frequency, normal, and we check all these conditions, and we saw that about one half of the, we found like 1/3 of the articles are completely unreliable. They're completely wrong. And I'm talking about 48 studies in the first two. In the first 2 reviews, we checked 12 studies of metals and 36 studies on organic byproducts. So 48, 1/3 completely wrong, completely wrong. 1/3 were okay and are completely reliable. And then you have 1/3 that are partially reliable, but you shouldn't take them, you should be suspicious about them, right? And so this was our result. We have it in a traffic light signal, that green is okay, reliable, red, reject, and yellow in between. So, because there are some that they did some of the things correctly, but not everything, so they get less points. So they shouldn't be trusted, really. The ones that can be trusted are 1/3. And yeah, 1/3 of the studies did it okay. They tested low power devices with a low airflow, and they pop them every 30 or 60 seconds. And the devices were new and all information was supplied. So and you can see that in all the green studies, the levels of toxic byproducts are negligible, are very small. And all the ones that report horrible byproduct levels, etc., are the red ones. Right? It is so clear, so evident. And this is the result. Now, we're also checking the studies that use these aerosols to expose cell lines and rodents. And we are seeing also the same. A lot of studies that expose, these are called the preclinical studies, right? A lot of them are using aerosols that are not, that a human would not use, right? So they are literally poisoning the cells and the mice. And we are now trying to, it's now on review, but we tested 40 studies of this type, and we have identified another 60. But it is a lot of work to do because you have to, we try to replicate each study. It's complicated. And we cannot replicate everyone because there are many studies that are very similar. And it's a lot of work. It's a lot of work, but I think it's valuable. And I think it puts the risk of electronic cigarettes in its right perspective, because people are starting now, there are a lot of people believing that e-cigarette use is as dangerous as smoking. And we're giving very hard science proof that this is not true. This is absolutely not true.